Okay guys, this is absolute value functions and their transformations. This is the formula for writing an absolute value equation in transformational form. This shouldn't be new to you. We've covered transformations before, and in the previous video I showed you the formula that looked like this that would help you get the vertex and the axis of symmetry from your H and K. So now we're just expanding it a little more to talk about the different types of transformations that take place. So one thing that you want to make sure that you do is that you understand that the values outside of the absolute value sign affect your vertical transformations, and what's inside are going to be your horizontal transformations. Now, some are going to be more important, not more important, but you'll see them more often than others. Normally in the focus of this class, we focus more on the vertical transformations aside from, like your value of H. But you just need to know the names of the transformations so that if you are given a function, you can tell me what transformations have taken place. So let's kind of go through this. So the properties, you should already know the properties of an absolute value function in this form. You should know that you can find your vertex from your H and your K and your axis of symmetry as well. Now, one thing that you always have to keep in mind, always, 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 is that you always change the sign on your H, okay, all the time. So if this is negative, in here it's going to be positive. If this is positive in here, then here it's going to be negative. So you always want to make sure to change this sign. So just make sure that you change the sign. This is so important. Okay, so let's go over our vertical transformations. We have the negative sign, which you're not always going to see there, but if you have a negative sign on the outside, it's going to be a vertical reflection, okay, over the x-axis. So that negative sign that you see here, that's your vertical reflection over the x-axis. What that means is if you have a graph of a function, a reflection over the x-axis, which is here, would flip it over this way. Okay, so that's what a vertical transformation would look like. Now, when we're talking about transformations, the negative sign and your value of A, we kind of evaluate them separately. So when we're talking about A, we don't take the sign of A into consideration because, we consider it a reflection. A here, you can kind of think of it as your slope of the line. Okay, so if we're talking about slope, you remember you start and you go up 1 over 1, up 1 over 1, up 1 over 1. Okay, that's your slope of the line. So you can kind of think of this value there as your slope. So if it's a 2, you go up 2 over 1, up 2 over 1. If it's a 1/2, you go up 1 over 2, up 1 over 2. Okay, so the values that you have in here for A are also going to give you transformations. So for your value of A here, if it's a decimal or a fraction, it's going to be a stretch, a vertical stretch. Okay, so V here just means vertical. It's going to be a vertical stretch. If A is a whole number, it's going to be a compression. Okay, so you need to know a vertical compression. So you need to know this term here and this term here. Stretch just means that it's going to get wider, and a compression just means that it's going to become more narrow. Okay, so that's your value of A, which you can also think of as your slope. Okay, and then your other vertical transformation is your K. So this one is just you take it as it is. It moves it up, down. Okay, so K here is going to move it up, down. If it's a positive 2, your graph's going to move up 2. If it's a negative, it's going to move it down. And by up and down, I mean transformations from the parent function. Okay, so you know that your parent function is this one here, the absolute value of x. So if we have a transformation of up 2, that means that your vertex is going to move up 1, 2 spaces. Okay, so from the parent function. And that's it. Okay, so these are your vertical transformations here. Now for your horizontal transformations, those are what's inside of your absolute value. Okay, if you have a negative sign, that's your horizontal reflection. Okay, so if there's a negative there, it's a horizontal reflection, which means that it flips over the y-axis. So if you have your function here, and there's a negative x, if this was going to be negative x, it would take it and flip it this way. Okay, so it would just flip over the y-axis. B here, that's also going to be, you can think of it as your slope, but it's going to be a little bit different. These are horizontal transformations, so they're opposite from here. So if B, which you can also think of as your slope, is a decimal or a fraction, it is going to be a compression. It's going to be a horizontal compression. And if it's a whole number, again, we're not looking at the negative sign. So if it's a -2 or a +2, it's by 2. Okay, so if it's a whole number, it's going to be a horizontal stretch. Okay, so the terms that you need to know are compression and stretch, and they mean the same thing. Stretch means to get wider. Compression means to become more narrow. Okay, so those are all of your transformations that you need to know. Your h, as you know, that's going to move your function left to right, and you always, always, always change the sign on your h. Okay, so your negative is your horizontal reflection, your b is your slope. That's either going to give you a compression or a stretch. H moves your graph left to right. K moves it up and down. The negative in the front flips it over this way, and A is your slope, which is also going to give you a stretch or compression. And one thing that you'll notice, but we won't explore a whole lot, is that these kind of work together. So if you have a vertical stretch this way, that's going to be a horizontal compression, because as you get wider, this way, it kind of flattens out your function, your graph this way. But don't worry too much about that. What we're going to focus on mostly, and what you'll see mostly, are these things. You do, however, need to know, if I give you a value in here, that it's going to give you, a horizontal stretch or compression. So make sure that you understand that. So I have a few examples. Given a function like this, you should be able to tell me all of the transformations and all of the properties just by looking at the function. So here I know that my axis of symmetry happens at h. This is a -3, so my axis of symmetry is the line x equals +3. Now you don't have to write that positive, that's just to show you that it changes from a negative to a positive. Your vertex happens at hk, again, where you change the sign, so +3, +2. As for my transformations, I have a negative here. That's my negative a, h, and k. Okay, so I have a negative, which means that I am going to have a vertical reflection. Okay, it's important that you can identify and tell me whether it's vertical or horizontal. A equals 2, that means that I'm going to have a compression, a vertical compression. And then the way you write it is by a factor of 2. H equals 3. Remember, you changed the sign. That means that it's going to have a horizontal shift of -3. Means it moves to the right 3 units. K equals +2 means that you have a vertical shift of +2, which means that it moves up 2 units. Okay, so what that means is, if you were going to graph this function, you would take the parent function that's there in the middle, you would move it to the right 2 units, or 3, and then you would move it up 2. You would flip it because of that negative, and then you would compress it, which means you would make it smaller by a factor of 2. So if I wanted to actually graph it, you start at your vertex, which is at 3, 2. You know that your axis of symmetry goes right down the middle. we know that it goes down, and we know that the slope is 2. So down 2, 1, 2 over 1. Down 2 over 1 in both directions. Okay, so then your graph would look something like this. So if you wanted to compare it to your parent function, you would notice that, okay, it moved. Sorry, so there's your parent function. You would notice, okay, it moved to the right, it moved up, it flipped, and it got more narrow. Okay, so it had a compression. Let's see, I have one more example for you, and then some practice problems. So if we look at this equation here, or this function, we know that our axis of symmetry happens at h. That's positive, so it becomes a -2. Okay, a, h, k. So a vertex would be at -2, -5. Transformations, there's no reflection. A equals 1/4 means that you're going to have a vertical stretch by a factor of 1/4. H equals -2 means that you're going to have a horizontal shift of -2, which means it's going to move to the right 2 units because it moves opposite. V equals, oh, I'm sorry, H here, that's +2. That would be +2, sorry, which means it's going to move to the left. Sorry, guys. V equals -5 means that you're going to have a vertical shift of -5, which means it's going to move down 5 units. All right, and that's it. So if you wanted to sketch the graph of it, you'd start -2, -5, 3, 4, 5, 1, 2, 3, 4, 5. Axis of symmetry goes through the middle. Your slope is 1/4, so up 1/4, 1, 2, 3, 4, up 1, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. Okay, so something like this. I feel 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 4, 1, 2. Okay. So like that, which is crazy wide. All right, so if you wanted to compare the transformations, it moves down, it moves to the left, and it gets wider. Oh, you can't see that. Okay, so from the parent function, moves down, moves to the left, and it gets wider. That's it for these examples. I have some practice problems for you. Okay. Make sure that you state the axis of symmetry, the vertex, and all the transformations. Sketch the graph. Make sure that you sketch the parent function. Which is f of x is equal to the absolute value of x. Okay, and then for extra credit, if you want to turn in, do this one. Okay, for this one, do all the same things and also give me a table of values. Have this ready for tomorrow for extra credit to turn in. All right, if you have any questions, let me know.